Look around you. Your phone, your car, the screen you're watching this on. Everything runs on tiny, intricate pieces of silicon, semiconductor chips. For decades, we took them for granted. Then, the pandemic hit. Suddenly, the world woke up to a harsh reality. The global supply chain, a marvel of modern logistics, ground to a halt. New cars sat and finished in lots, not because of engines or steel, but because of a shortage of tiny, fingernail-sized chips. We were all caught off guard, realizing just how dependent our entire civilization had become on a handful of advanced manufacturing hubs, thousands of miles away. This wasn't just an inconvenience, it was a wake-up call. The smooth, invisible flow of technology that powered our lives was far more fragile than anyone imagined. The era of easy access was over, and a new, more contentious chapter was about to begin. The great global chip war had just fired its opening shots. The world's response was swift and decisive. A technological arms race, unlike any we've seen before, ignited across the globe. Governments in the United States, Europe, and Asia began pouring hundreds of billions of dollars into one single goal: bringing chip manufacturing back home. The era of outsourcing critical technology was declared dead. This is the new frontier of national security and economic sovereignty. We're seeing the rise of massive construction projects, futuristic megafactories called fabs sprouting from the ground. These aren't just buildings. They're technological fortresses, designed to secure a nation's future. The scale is staggering. A single fab can cost over $20 billion and cover an area the size of multiple football fields. But this rush for self-sufficiency comes with its own immense challenges. These fabs are incredibly thirsty. A single plant can consume as much water as a small city and require a dedicated power station just to keep the lights on and the machines running. The logistical and environmental hurdles are enormous. We're talking about a massive strain on local resources, from water supplies to the electrical grid. The quest for technological independence is reshaping not just global politics, but the very landscapes where these new industrial titans are being built. So what exactly happens inside these technological cathedrals? Welcome to the clean room, an environment 1,000 times cleaner than a surgical operating room. Here, a single speck of dust can ruin an entire batch of chips worth millions. Workers clad in head-to-toe bunny suits move like astronauts in a sterile, yellow-lit world, designed to protect the delicate manufacturing process from even the smallest contaminants. The journey of a chip begins with a thin, perfect disk of pure silicon, called a wafer. This wafer undergoes hundreds of complex steps in a process that can take over 3 months to complete. Machines costing tens of millions of dollars use a process called photolithography, using extreme ultraviolet light to etch impossibly small patterns onto the silicon. We're talking about circuits with features measured in nanometers, a scale so small that it's hard to comprehend. A single nanometer is about the width of just a few silicon atoms. This is atomic-level engineering. Layer by layer, through deposition and etching, these intricate three-dimensional structures are built up, creating billions of transistors on a single chip. It's a symphony of chemistry, physics, and robotics, all orchestrated with near-perfect precision. This is where the magic happens. This is where sand is transformed into the brains of our modern world. The complexity doesn't end there. Controlling this technology is about more than just building gadgets. It's about raw power. The nation that masters advanced semiconductor manufacturing controls the future of everything: artificial intelligence, 5G communication, autonomous vehicles, and next-generation military hardware. A country without its own advanced chips is at the mercy of others. It's a strategic vulnerability that no major power is willing to accept any longer. This is why the chip war is so intense. It's not just a trade dispute. It's a fundamental struggle for global leadership in the 21st century. The ability to produce the most advanced chips, the so-called sub-5 nanometer nodes, is a capability held by only 2 or 3 companies in the entire world. It's an exclusive club, and the price of admission is immense. This technological supremacy translates directly into economic dominance and military superiority. The fighter jets of tomorrow, the supercomputers cracking complex codes, the AI that will redefine industries, they all depend on having access to the best chips. In this new global landscape, silicon is the new oil. It's the strategic resource that will define winners and losers for decades to come. So, what does the future hold in this high-stakes game? The race for smaller, faster, and more powerful chips continues unabated. But a new front has opened up in this war: sustainability. The massive energy and water consumption of these fabs is no longer sustainable in a world grappling with climate change. The next great innovation won't just be about cramming more transistors onto a chip. It will be about how to do so with a smaller environmental footprint. We're seeing a push for fabs powered by renewable energy, for advanced water recycling systems that can recapture over 95% of the water used. The industry is being forced to reinvent itself, not just technologically, but environmentally. Simultaneously, the geopolitical chessboard continues to shift. As more countries develop their domestic capabilities, the global supply chain will become more fragmented, but also potentially more resilient. We are moving from a unipolar world of chip manufacturing to a multipolar one. One thing is certain: semiconductors will remain the bedrock of our technological civilization. They are the fundamental building blocks of the future. The battle for control over their creation is more than just a corporate rivalry or a political squabble. It is the defining contest for the future of global influence, and it's happening right now, 1 nanometer at a time. Thanks for watching, and if you found this journey into the world of chips fascinating, be sure to subscribe for more deep dives into the technologies shaping our world.